Limiting reactant or limiting reagent, excess reactant and super easy trick to calculate limiting reactant and excess reactant. At the end of this lecture, I will teach you numerical questions. Firstly, let me teach you the daily life example of limiting reactant and excess reactant. For example, consider one man and one woman. Let they get married and become parents. Secondly, consider 5 men and 4 women. We know that only one man can marry only one woman. Now here are 5 men and 4 women. Thus 4 men will marry 4 women and we will get 4 parents. Here, unfortunately, one man like me is left behind. Now listen carefully. We say that 4 women are limiting reactants and 5 men are excess reactants. If you ask me how it is possible, the answer is simple. All these women are completely married to 4 men, so not a single woman is remaining. Hence it is a limiting reactant. On the other hand, out of these 5 men, only 4 men are married and one person is still waiting for a woman to marry him. Hence it is an excess reactant. Thus remember that limiting reactant is the first reactant that is used up completely in a chemical reaction. Secondly, once limiting reactant is completely used, no more product can be formed. For example, when 4 women completely accepted 4 men, the process of marriage stopped, even though this unlikely person is still waiting. While the excess reactant is the leftover reactant after the chemical reaction stops, or we can say that it is the unused reactant. For example, like this man is still waiting. Thus remember the concept of limiting reactant and excess reactant. Now let me clear one biggest confusion or misconception about limiting reactant. A lot of people learn that limiting reactant is the least amount content in any chemical reaction. It is totally wrong and misconception. For example, consider 3 men and 8 women. Now every man is permitted to marry 4 women. So the 2 men will marry 8 women and one person is still waiting. Believe me, I laughed a lot while writing this script and especially I feel sympathy for this unlucky man. Thus here all the women are successfully married. Hence being greater in amount, they are still limiting reactants. And men being lesser in quantity are still excess reactant. Therefore remember this important concept about limiting reactant. Now let me teach you the easy trick of identifying limiting reactant and excess reactant. For example, consider 5 moles of carbon and 2 moles of oxygen gas react together to form carbon dioxide gas. Firstly, I balance the chemical reaction. We can see that it is already balanced chemical equation. I write 1 and 1. Now I will find the simplest molar ratio between carbon and oxygen. For instance, I divide the number of moles of carbon by its coefficient 1. Similarly, I divide the number of moles of oxygen by its coefficient 1. So I get 5 and 2. Here 2 is smaller than 5. Hence we say that oxygen is limiting reactant and carbon is excess reactant. Thus remember that the reactant which has the smaller ratio is the limiting reactant and the other one is excess reactant. Secondly, consider this chemical reaction, where 3 moles of methane gas react with 5 moles of oxygen gas to form carbon dioxide and water. I balance the chemical equation. I write here 1, 2, 1, 2. Now I find the simplest ratio between methane and oxygen gas. I divide 3 moles of methane by its coefficient 1. Also, I divide 5 moles of oxygen by its coefficient 2. I get 3 and 2.5. Here 2.5 is smaller than 3 Hence, oxygen gas is a limiting reactant and methane gas is an excess reactant. Thus, by this way, we can easily spot the limiting reactant and excess reactant in any chemical reaction. Now, let me teach you numerical questions. For instance, what is the amount of H2O that can be made from 5 moles of H2 and 2 moles of O2? Find the limiting reactant, excess reactant, and amount left over in the chemical reaction. Well, firstly, I write number of moles of hydrogen gas taken, which is equal to 5 moles. Also, I write the number of moles of oxygen gas taken, which is equal to 2 moles. Then I write the balanced chemical reaction. Now I am going to spot the limiting reactant and excess reactant in this chemical reaction. Here, hydrogen gas and oxygen gas are reactants. I write 2H2 and oxygen gas. The number of moles of H2 taken is 5 moles and that of O2 is 2 moles. I divide the number of moles of H2 by its coefficient and also that of oxygen by its coefficient. I do so in order to get the simplest ratio between them. I get 2.5 and 2. Here, 2 is a smaller number than 2.5. So, oxygen is a limiting reactant and hydrogen is an excess reactant. Secondly, I calculate the number of moles or amount of excess reactant left over in the chemical reaction. Well, I write the ratio of limiting reactant and excess reactant. The limiting reactant is oxygen gas O2 and excess reactant is hydrogen gas H2. In the chemical reaction, the coefficient of hydrogen is 2 and that of oxygen is 1. Let me repeat this important point. In the chemical reaction, the coefficient of hydrogen is 2 and that of oxygen is 1. So the ratio of oxygen to hydrogen is 1 to 2. Now listen carefully. The limiting reactant is oxygen gas O2. So its 2 moles is completely used in the chemical reaction. So I write here 2 moles of oxygen. Now using this ratio, we can easily calculate the number of moles of H2 used in the chemical reaction. So I write here 2 and for H2 I write X. After cross multiplication, I get X is equal to 4 moles. Thus 2 moles of oxygen gas reacts with 4 moles of hydrogen gas. Or we can say that 4 moles of hydrogen is used. On the other hand, we have taken 5 moles of hydrogen gas. So we subtract number of moles of hydrogen gas taken minus number of moles of hydrogen gas used in the chemical reaction. I mean 5 moles minus 4 moles. I get 1 mole. So 1 mole of hydrogen gas is left over in the chemical reaction. Thus the excess number of moles left over of hydrogen gas is 1 mole. The third step is to find the number of moles of H2O formed in a chemical reaction. I write the ratio between limiting reactant and product. The limiting reactant is oxygen gas O2 and the product is water H2O. In the chemical reaction, the coefficient of oxygen gas is 1 and that of water is 2. So the ratio of O2 to H2O is 1 to 2. We know that oxygen gas O2 is limiting reactant and we have taken only 2 moles of oxygen gas O2. So using this ratio, we can calculate the number of moles of H2O formed. Let it is X mole. After cross multiplication, I get X is equal to 4 moles. Thus the number of moles of water formed in this chemical reaction is 4 moles. Therefore, we say that 5 moles of hydrogen gas and 2 moles of oxygen gas react together to form 4 moles of water. Hence, note it down this numerical question. Now, let me teach you one last numerical. What mass of carbon dioxide gas formed in a reaction of 20 grams of glucose with 50 grams of oxygen? Well, in such type of numericals, firstly, we convert the given mass into number of moles. If you do not know how to calculate number of moles, watch our video and its link is given in the description. Now I calculate the number of moles of glucose. 20 grams divided by the molar mass of glucose, which is 180 grams. I get 0.11 moles. Secondly, I calculate the number of moles of oxygen gas, which is equal to 50 grams divided by the molar mass of oxygen gas, which is 32 gram. I get 1.56 moles. Thirdly, I write the balanced chemical reaction. The number of moles of glucose is 0.11 moles and that of oxygen is 1.56 moles. I find the simplest ratio between them. I get 0.11 and 0.26. Here, 0.11 is a smaller number than 0.26. Hence, glucose is a limiting reactant and oxygen gas is an excess reactant. Secondly, I calculate the mass of carbon dioxide gas formed in the chemical reaction. I write the ratio between limiting reactant and product. The limiting reactant is glucose and the product is carbon dioxide gas. According to their coefficients, the ratio between them is 1 to 6. We know that the limiting reactant is glucose and we have taken 0.11 moles of glucose, which is completely used in this chemical reaction. So using this ratio, we can easily calculate the number of moles of carbon dioxide gas formed. Let it is X mole. After cross multiplication, I get X is equal to 0.66 moles. So the number of moles of carbon dioxide gas formed is 0.66 moles. But wait a minute, we are asked about the mass of carbon dioxide gas formed. Well, we multiply the number of moles of carbon dioxide by its molar mass, which is 44 gram. I mean 0.66 moles into 44 grams. I get 29.3 grams. So 29.3 grams of carbon dioxide gas is formed in this chemical reaction. Therefore, we say that 20 grams glucose and 50 grams oxygen gas react together to form 29.3 grams of glucose. I hope that you have learned all about limiting reactant and excess reactant.